Hello, how do we find the general solution of sec 2 theta at pi over 2 is equal to 2? Again, a compound angle. We know that sec theta is equal to the reciprocal of cosine theta. So we can rewrite this as 1 over cosine of 2 theta at pi over 2, and this is equal to 2. Now if you want to find the cosine, or express this in terms of cosine of a compound angle, we have to just find the reciprocal of the left and the right hand side of this. The reciprocal of the left hand side will give us cosine theta at pi over 2, and the right hand side, it's a half. So now we have something familiar that we can work with. The principal value of cosine theta at pi over 2 is pi over 3. So that. So thus we can write that 2 theta at pi over 2 is equal to 2n pi plus or minus pi over 3. Gives us 2 theta is equal to 2n pi minus pi over 2 plus or minus pi over 3, which gives us that theta is equal to, here we're multiplying by a half both left and the right hand side, give us n pi minus a quarter pi plus or minus a sixth pi. So this final result is our general solution to sec 2 theta at pi over 2 equal to 2. Thanks for watching this video. My name is Alistair. Bye for now. Hi. In this problem, we're going to eliminate theta from these two equations, and we'll do this by using a trig identity. Now, we have that cosine theta for this equation is equal to x over 4, and sine theta is equal to y over 3. Now, if we use cosine square theta add sine squared theta identical to 1, then we get that we have x over 4 squared and y over 3 squared, and this is equal to 1. Now this will give us x squared over 16 and y squared over 9 is equal to 1, which implies that we can write x 9x squared and 16y squared is equal to 144. So we've used a trig identity, cosine squared theta and sine squared theta equivalent to 1, to eliminate theta from these two equations, giving us an equation in x and y. Thanks for watching. I'm Alistair. Bye for now. Hello. How do we find a general solution of sec 2 theta at pi over 2 is equal to 2? Again, a compound angle. We know that sec theta is equal to the reciprocal of cosine theta. So we can rewrite this as 1 over cosine of 2 theta at pi over 2. And this is equal to 2. Now if we want to find the cosine, or express this in terms of cosine of a compound angle, we have to just find the reciprocal of the left and the right hand side of this. The reciprocal of the left hand side will give us cosine theta at pi over 2, and the right hand side, it's a half. So now we have something familiar that we can work with. The principal value of cosine theta at pi over 2 is pi over 3. Let's write that. So thus we can write that 2 theta at pi over 2 is equal to 2n pi plus or minus pi over 3. Gives us 2 theta is equal to 2n pi minus pi over 2 plus or minus pi over 3, which gives us that theta is equal to, here we're multiplying by a half both left and the right hand side, give us n pi minus a quarter pi plus or minus a sixth pi. So this final result is our general solution to sec 2 theta at pi over 2 equal to 2. Thanks for watching this video. My name is Alistair. Bye for now. Hello there. A few more questions on solving trig equations. For the range theta lying between 0 and 360 degrees, solve the equation cosine theta over 2 is equal to 0.85. First we'll let theta over 2 be identical to phi. Then we can write that cosine phi is equal to 0.85. The cosine inverse of 0.85 is 31.79 degrees. So the principal value, PV, of phi is 31.79 degrees. Now, the required range is 0 to 360. So the range of phi, which is theta over 2, is 0 to 180. So we have phi is equal to 31.79 degrees, which gives us that theta is 63.58 degrees. If we look at it in a quadrant diagram, 31 lies in this quadrant, and it's positive. Cosine half of theta is positive. We're restricted to theta lying between 0 and 360 degrees. The other quadrant where cosine is positive is in the fourth quadrant. In that case, our value will not, any other values will not fit into this range of 0 to 360 degrees. So the only solution to this equation within this range is theta equal to 63.58 degrees. Thanks for watching this video. My name is Alistair, and I'll see you in the next one. Hi, here's another problem. For the range theta lying between 0 and 360 degrees, solve the equation 10, 2 theta equal to 1. Let 2 theta be identical to phi. So then we have 10 phi is equal to 1. Now the principal value of phi is pi over 4. So tan inverse of 1 is pi over 4, or 45 degrees. Now in terms of phi, our formula that we use is pi n degrees. Now this implies that theta is, we have 2 theta is equal to phi. So in order to find for theta, or 1 theta, we'll find half of this expression here, or divide by 2, which gives us pi over 8, pi over 2 n degrees. So this is a formula we'll use to calculate theta. And the values of n that span the required interval, and that's 0 to 360 degrees, is n equal to 0, 1, 2, and 3. Now this is something I've calculated based on the values I'll now write for theta. So theta will have these values: 25.5 degrees, 112.5 degrees, 202.5, and lastly 292.5. Always check that your largest value of theta lies within this range, 0 to 360 degrees. And that's it. Thanks for watching this video. My name is Alistair. Bye for now. For the range 0 to 360 degrees, solve the equation sine 3 theta equal to 0.7. Again, we start with letting 3 theta be identical to phi, so that we can write sine phi is equal to 0.7. Now our principal value of phi is 44.43 degrees, and our secondary value is 135.57 degrees. On our quadrant diagram, something like this. And then we have, angle somewhere in here. And this is 135.57 degrees. Now, using the formula for the sine ratio, 360 n degrees, where n belongs to the sets of integers. Now we have phi. Using the formula, we have values of phi. We start with 44.43 and 135. Call this 135.6. 404.43. Now these are all based on variant values of n, and bearing in mind that we'll take a third of these values, which will give us the value of theta. Remember, phi is 3 times theta, so in order to find theta we want a third of phi. So these are our values. We have 4, 9, 5, 6, 764.4 and 855.57, and theta, therefore theta 14.8, 45.2, 134.81, 165.2, 254.8, and lastly 285.19 degrees. I'll leave it as an exercise for you to check to see what values of n were used in this formula to calculate our values that lie within the range 0 to 360 degrees. It's a good idea to go through that and see where your limits are. This is just a case of substituting values of n and checking that you lie within the range of 0 to 360 degrees. Remembering also that phi we substituted here, 3 theta being identical to phi. So when we have our values of phi, we need to find a third of each one of these values to get our values of theta. Thanks for watching this video. My name is Alistair, and I'll see you on the next set of videos. Bye for now. Hello mathematicians. Solve the equation cosine 4 theta is equal to cosine theta. What do we know? We know we know that cosine theta equal to c, and where theta is equal to plus or minus theta at 2n pi. This is the formula we derived if you look at my previous videos. Instead of the principal value, we use theta. So we can write that 4 theta is equal to 2n pi plus or minus theta. And so we have two options here. We can write that we have 4 theta with minus theta will give us 5 theta, and that's equal to 2n pi. Or we can have 4 theta with plus theta. When we take it to the other side, we have 3 theta is equal to 2n pi. So now we have theta can be equal to actually 2n pi over 5, or we can have theta being 2n pi over 3. Don't take my word for it. Substitute integer values for n and check that when you take cosine of theta, that value is also equal to cosine 4 times theta. Thanks for watching this video. My name is Alistair. I just realised this is not clearly on the screen. Let's write this, rewrite this. So this is 2n pi over 5, or 2n pi over 3. Thanks for watching this video. Bye for now.